Hello everyone, Sean, having fun repairs. Welcome back to the channel. I've got with me an Onkyo TX-Sierra Romeo 353 AV receiver. There we go, model number right here. You can see it yourself. With a customer who said that they were getting a loud hum at every speaker, or hum at every speaker, and until they and to get rid of it, what they had to do, and I left a little sticky note right here, is they'd have to tap it on the front, and that would get rid of the hum. Okay, as a matter of fact, he said he had to tap it right there. So if you recall from one of the previous videos I did on a plate amplifier for a subwoofer, when I touched the RCA leads going into it, actually I got them down here, these RCA leads here, you notice that I reintroduced something into the input of the audio circuit. It was a 60 hertz signal, and then when I changed the volume knob, we saw that 60 hertz signal increase in amplitude. Okay, so essentially what causes this hum at your speakers is something that's naturally occurring anyways. When you plug in your audio equipment into an outlet, it's presented with around 120 volts AC at 60 cycles or 60 hertz. Okay, and so what happens we get to the stage of rectification to start developing the DC voltages that we need from our AC voltages. We typically have filtering done by some pretty massive capacitors. And those capacitors are designed to filter out the actual 60 cycles or 60 hertz signal, so that way it's not kind of like a choke per se, I guess, but so that way it's not occurring within our DC stage, because obviously that would create oscillation and you don't want that in DC. But also so that way it's not getting inducted into our audio stage and we're not hearing it at the speaker. Okay, so it's important that we have filtering, especially on AC lines voltage, in audio equipment wherein we are reproducing audio from a tertiary source. Okay, and so what had happened in that video, when I was touching basically my thumb across the ground outside of our RCA connector here and then to the tip or the center conductor, is I was reintroducing that 60 cycles or 60 hertz signal back from the chassis to the input of what was supposed to be our tertiary audio source. Okay, so I think that's a very layman's way of putting it. At least I think for general purposes, I think that's a decent way of describing it. So what does that mean? Well, I mean, I'll power this on for a second and we'll listen, but we're most likely not going to hear that hum across any speaker I attach to it. And the reason being is this is an intermittent issue, which tells me that we have to have we have to introduce how this equipment is being used on driving an audio source to amplification and out to a speaker, which means that this device has to start producing heat, which is a byproduct of eating energy from an outlet. Okay, because you can't, basic science theories tell you that energy can neither be created or destroyed, only converted, right? So we convert a lot of that energy that's being used into heat, and that's why electronics get hot. Okay, so they go through resistors and transistors and MOSFETs and anything. That's why they warm up. We're converting one energy into another. That's basically it. So, well, what does heat do? Well, heat has an effect on electrolytic capacitors. That's the primary reason why a lot of them fail. Okay, there could typically be no other issue within a audio amplification system, such as a receiver here, outside of capacitors. As a matter of fact, if you watch this channel and many other channels, what is the primary component being replaced in every single thing? Capacitors, 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 capacitors. Yeah, electrolytics, they dry out, they get leaky, and when that occurs, they are not filtering as they should. If they're being used for filtering or any other general purpose, okay, bypass capacitor or whatever, it's not performing as it should function. And when that occurs, like what we're getting with this, is that 60 cycle signal, 60 hertz, coming from the outlet, instead of it being filtered to the chassis, okay, and not present or inducting over onto our speaker outputs through the audio circuitry and amplification that occurs within here, it's no longer performing those functions. But how do I test that? Well, I would essentially have to turn this on, and I'm going to have to let it ride for hours and hours and listen, and then tap it myself once it's there just to confirm, oh yeah, it's humming. When really what I could probably do, actually AM's on right now, why don't we hook a speaker up to this? I'll just put this to the center channel. Okay. I can tell the filter on my microphone is trying to cut out a lot of this static that we're hearing right now. Let me turn the filter off. Noise suppression off. Turn the filter back on. Did any of y'all hear hum coming across that speaker? No, nor would you, because we really haven't met the conditions in order for this fault to occur. Again, this needs to run, it needs to get warm, and that heat is going to have an effect on the electrolytic capacitors that are in here. And if they are old and leaky, then we'll start seeing those issues. So, how am I going to go about this so I'm not wasting 2 hours time just listening, waiting for a symptom to occur? I'm going to go ahead and take it apart. I'm going to start looking at the power supply and those capacitors first. Now that I've got just the top cover off the chassis and we can peer down into it, I'll give you a brief second. Can anybody identify some potential issues? And now that you've had a second to look, maybe you can pause it at this time and look even more. I can give you no less than 2 issues that I see. The first one is incredibly apparent. There's a lot of dirt, dust, or, build up. You can see all that dust just right off my finger. Yeah, dust is not good. It helps trap in heat, makes things operate hotter than it should. So when it comes to your audio electronics, you really should, on occasion, unplug it, and at least come in and blow out all the dust, okay? That's not good for the lifespan of your system, per se. So that's something that I'll have to address. That's number 1. And then number 2, okay, take a look at these two 65 working volt 6800 microfarad caps. You see anything weird about them? Let me try and tilt this up. Maybe it'll look a little bit better for y'all. Do you see how bulged the tops of these are? As a matter of fact, I think this one's actually been leaking. Both of these caps right here are bad. Any cap with a bulging top is representative of it venting, meaning that it's gotten too hot, or maybe it's had an internal short and it's had to bulge out in order to vent, which means that these caps are bad. They're probably very leaky. And even though when we turn it on, we don't immediately, as demonstrated, hear that hum, well, as the temperature builds up inside of here and has an effect on those two, and these are our primary filter caps coming right behind our full wave bridge rectifier down in there, that's what's going to be the primary cause for why we hear hum out at our speakers, because essentially instead of that 60 cycle or 60 hertz signal going to the chassis, it's now being loud. Basically, it's these caps, what's the best way for me to put this? They're becoming noisy, okay? And that noise will get picked up, especially over here at our audio amplification circuit, because here's where we have all of our strand of probably Darlington transistors. Where are they at? Yeah, all back, right back in here, okay? And so, yeah, there's a little bit of shielding between here and this board, but remember, this board is also housing the components that are driving those paired transistors or MOSFETs or whatever is being used for amplifying our audio signal. So I will need to get these two caps replaced. I'll probably have to dismantle this and test a few more caps. We'll have to get it clean, but this is going to be the primary issue for why that hum is there. So I'll let the customer know and order some parts, and we'll go from there. Disassembly is complete now. I've gotten everything apart and cleaned up as well for the most part. So now it's going to be time to remove these 6800 microfarad capacitors, get them replaced. I think these are snap-in, and that's exactly what I ordered as a replacement. Looks like the standoffs for the pins are approximately the same. It's very possible that the board is marked for the polarity, but just in case it's not, I'm going to put a little silver dot here and here using a Sharpie marker. And I think I'm going to replace this one as well, so I'll put a little dot there, and we'll see how it does. These capacitors removed, why don't we do a quick check on them? I have my multimeter set to capacitance, and 6800 microfarad is nominal rating. What are we getting? 6198. 6198, I think, would still be in 10% tolerance. 6198. Yeah, that would be closer to the lower end on a 10% tolerance. And these probably have a 20% tolerance. What you willing to bet that this one is probably the same thing or close to it? 6.2, yeah, close to it. Regardless of the fact it's supposed to be closer to 6,800, and so you would most likely think, oh, it's within tolerance, should be good. But I mean, really, look at how much it's bulged. No, it's not good. I guarantee you. And look, they can't even sit flush. I guarantee you they're not good. Unlike our new ones here. This one's 6,800. Now I got a 80 volt because 65 working volts wasn't very common. You can go higher up on the voltage rating. I'm not too worried about that. But the main reason why I selected these Nichicons for replacement, 6256, yeah, 63. Yeah, they read lower, but still within 20% tolerance. These haven't vented though. Like I said, once these heat up, you're going to see that they're very, very leaky. If I had a leakage tester, we would be able to see that as well. I just don't. Uh, the 6320. Yeah, it's going to be within the 10% or 20% tolerance. But the main reason why I got these is because if you look at the uh, temperature rating, we have 105 degrees Celsius versus 85 degrees Celsius. So these are going to be a little bit more heat resistant, which is going to bode better for us on for lifespan of this AVR, audio visual receiver home theater system. We're going to go ahead and replace this one too. It's a 330 microfarad, although I doubt that, yeah, it's within tolerance. So I doubt this guy is bad. If we were to put it on leakage tester, I'm pretty sure we wouldn't see it as bad. But again, the reason why I decided to go ahead and replace this one versus what's in there has a lot to do with the actual temperature. And I went with a Rubicon 80 volt 330 microfarad replacement cap. So let me go ahead and get these soldered into there. And I need to get this thing buttoned back up. Got it for the most part back together. Let me plug it in and turn it on. There it is, plugged in. Hopefully no explosions. There we go. There we go. Okay, so it's on. let me get this set up for Bluetooth, and we'll check the each output. Okay, I was watching a tad bit of Kip Hakes while I was putting all this together, so let me check out his channel. But anyways, let me go to this. I got a 1 kHz tone coming in. You can see that up here on the SIGGEN. And this is currently connected to our surround left speaker. Let me increase the amplitude. Let's see, what do we get up to? Looks like at volume of 76, we're seeing 76.8 volts peak to peak on the O-scope. Okay, so I'm going to turn the volume down. And that looks like a pretty nice signal. If we were getting hum, it would show up as a kind of distorted signal. So we'll now move over to surround sound, surround right. Okay, and I got the surround right speaker in. Turn up the volume. And I went ahead and zeroed or made all the speakers as close together as far as their, control settings are, distance, gain, etc. 76 volts at 77, 78, 79, 76.8 at max. So again, that's looking equal. That's a nice, pretty signal right there. Let me go to our center channel. All right, now I'm on my center channel. Take the volume to the max again. I think center channel is at a slightly different level. I'm getting 48 max. Let me double check that. Yeah, double checked it. So yeah, all the distances are set to 6 feet. And then the preset gain is all set to 0. So that could be a slight issue with the center channel, but that's not what we were here to troubleshoot. Just the hum, which we knew is coming from the power supply and those leaky capacitors. Let me go off the center channel and to our front left. And again, even that could not be an issue. I don't know enough about the output of these receivers to know if it needs to be at 48 on center or 72. That does seem a tad bit low to me, though. Let's go to our front left speaker. All right, I'm on my front left speaker, and yeah, max 79, 80. So yeah, there might be an issue with that center channel being pulled down a little bit, or the center channel just could have a slight issue. All right, there's a touch of distortion on that surround left speaker. All right, we're now on the front right. And yeah, we get a touch of distortion when we go to max on the front right. Okay, last I need to check is, let me turn this down. Hopefully that distortion isn't coming from my phone. You can see it kind of along the bottom and upper envelope of our sine wave. Most likely with the filtering caps that we needed to replace because they were bulging. There could potentially be issues with the drivers for each channel, either Darlington transistors or MOSFETs or something. It could be about time to replace them. But for now, this is just power supply recap job. I do need, like I said, I need to check our subwoofer, make sure that is still providing an output. And then I'll let the customer know what all I've seen on this on our receiver, and if he wants to have me troubleshoot and resolve those other issues at a future time, then that's perfectly up to him. If not, we'll end up calling this one good. I'm not seeing 60 hertz hum. Pretty sure if I listen to it with a speaker attached, we won't hear it either. So actually what I need to do, give me 1 second. Okay, I got a little test rig RCA cable that's been spliced, and my oscilloscope is connected to it on the other end. But yeah, 1K hertz signal is definitely not going to come over sub. Let's do 80 hertz. Okay, and I'm starting to see something. Let's see. Let me increase the amplitude a tad bit. Yeah, there goes our 80 hertz signal. So we're at 10 volts max here. Okay. I would expect that should be a bit higher, but I'm not too sure. That's not a sub pre-out, otherwise it would be low level audio. Again, I don't have this connected to like a 6-ohm speaker, so that could be one of the reasons why it's probably not allowing it to go any higher than that. But what happens if I change the frequency? Will it the amplitude increase? I mean, we can see that the frequency changes at the lower. Yeah, amplitude increases a little bit. So this could also be the way the crossover is set up as well. But at minimum, we're getting audio out, and it doesn't look too bad. It's a nice, pretty sine wave. I can get down to 40 hertz, have it distorted, but it really doesn't look too bad. Alright, so this is going to do it. I'm going to get this buttoned up and email the customer and let them know that we've replaced the power supply capacitors. That should eliminate the 600, the 60 hertz hum that he was getting in over all the speakers. However, it does appear that his center channel is starting to potentially going out, and he's got some distortion on the other speakers, which could be transistors going bad. But yep, anyways, and if this ends up back on the bench, then it ends up back on the bench. All that being said, thank you for watching. If you enjoyed this video, again, if you're working on an AV receiver, if you get 60 hertz toms or your speakers, check your power supply caps. Those are primary fault, that type of stuff. But if you enjoyed this video, please consider subscribing to this channel. If you're new, give this video a thumbs up. Let me know what you think in the give me your comments in the little description down below. If you're in need of repair, reach out to me through email. There is a link to my business webpage. It's in the description of every video. That tells you how to get in contact with me, and we can work out a repair for you. Anyways, I'm rambling at this point. Thank you for watching. Take care, and goodbye. Bark.